Hello, I'm Anthony. Welcome to this new tutorial series in which we're going to deconstruct the Xils-4 synthesizer by Xils-Lab. This is an emulation of an analog synthesizer that only ever reached the prototype stage in 1970. EMS were looking to supersede the VCS3, the very famous and successful synthesizer. Basically, they plugged two VCS3s together. You can see these basically the two separate synthesizers sat together. Then they added a keyboard, put it all in a shell. Only two of them were ever made. It never reached production, but this thing is a fantastic sounding synthesizer. It goes beyond simply two VCS3s and has some pretty unique circuitry itself. If you enjoyed this series and you want to help support my channel, check out the Patreon and YouTube channel member links below. Awesome way to do that. I've decided to take a slightly unusual approach for this first episode in the series. Ordinarily, I would dive straight into one of the components of the synthesizer and start talking about it. Ordinarily, I start with the oscillators. We're actually going to deal with that in the next episode. Today, what I'm going to do is a preset deep dive. I'm going to take one of the initial presets in the factory Xils-4 library, and I'm going to deconstruct this preset to show you some of the primary features of the synthesizer. One of the complexities and difficulties with modular synthesizers, this is a modular synth, is that they have all of these individual components, and it's only when you plug them together that they actually make any sense. So I've decided to actually show you an entire modular patch, this preset, and we'll pull it to bits and we'll see some of those examples, some of those modules in real world use. So the thing sounds like this. There's an awful lot going on in that sound, that simple sound. There's a lot to talk about. And the majority of our conversation today is going to be around these two black squares. These are called matrices. We have the standard matrix and the advanced matrix. And over the course of today, I'll show you how the various components of this synth are plugged together to make that init sound. And you'll be able to follow along with this yourself. Everybody's got access to this basic factory preset. Now, the first thing that I want to do before we go any further today is disable portamento. If I play two notes, you hear that glide from one note to another. That's going to confuse some of the other features that we're talking about today, so I'm going to turn it off. Portamento is down in the bottom right hand corner of the keyboard module. I'm going to click that and turn it off. Now each note is played individually. Oh, just as a matter of interest, this interface that we're looking at here, I've set it to 61%. You can set your display size, GUI size, here it is, I've got 61%. I've also got all of the modules engaged. You see you can turn some of them off. And I'm also in full synth mode. This little button on the left hand side. This is basically like a truncated version if you've got minimal real estate. I'm going to display it in full view and talk about it from this perspective. So beyond saying that, I'm not going to really talk about the different interface options. I like to see everything all of the time. Fortunately, I've got a big enough screen to be able to get away with that. So I've turned portamento off, and here we've got our really simple sound. Now we're going to start to pull this thing to pieces to figure out how it works. Now, one of the most important things to realise about modular systems is that you can't take anything for granted. Simply because we have a keyboard, you can't presume that you play the lowest note on the keyboard, and you get a low note, and the highest note makes a high note. You have to tell the modular synthesizer to do that, and we're going to see all of those things today. The first and most important thing for us to do is to hear a sound when we press a key, and we're going to access that from this little keyboard section. Each feature that I talk about today, each section that I address, we're going to go into much more detail later on in the tutorial series. This is a very holistic overview, but we've got these little magnifying glasses, and if I click it, it pops up a magnified view of various options available to us for our keyboard routing. Now, as it happens, for reasons that we'll get onto when we talk in more depth about the envelope shaper, we don't actually need this gate pin. So I'm going to right click it. That pin has just gone away. What I did there was disable one of the matrix connections in this synthesizer. So down the left hand side, we have our sources or inputs. These are the things that are supplying information or signals somewhere else in the synthesizer. So when you hold a key down on the keyboard, what you've done there is you've opened a gate, and for as long as you hold that note down, the gate is open. When you let the key go, the gate closes. In this particular preset, we don't need gates, so I've just disabled it. Immediately above it, we've got another pin. These little connections in the matrix, you can see as I'm moving around the matrix. Wherever you click, left click creates a pin, right click disables the pin. And that creates a connection between the source on the left-hand side, or the input, and the destination or output across the top. So our keyboard, when we press a key on the keyboard, that's generating a keyboard on trigger. So every single time I press a note on the keyboard, this trigger fires. The difference between a trigger and a gate is that a trigger is an instantaneous moment in time. It happens and then it's done. A gate has a beginning, a duration, and an end. So pressing the key is a trigger, holding the key down is a gate. We're interested in the keyboard on, that's a trigger, and it's going to this curiously titled thing, Trap L. Now Trap stands for Trapezoid. It's a very fancy name for a fairly simple shape. It's basically a rectangle with your two sides caved in. So we have basically a slope leading up to a flat line at the top, and then a descending slope. That trapezoid shape is going to be used a lot in this synthesizer, and you'll see it named all over the place. This is one of the first instances we've come across it. And what's actually happening is when you press a key on the keyboard, our keyboard on trigger is sending that signal to a thing called an envelope shaper, and that ultimately is going to be what generates the sound. I'm going to talk a little bit more about trapezoids later, but just for now, let's say we're done with that section. We've figured out how to generate a trigger off the keyboard and make it do something somewhere else in the synthesizer. We'll worry about what later. So let's step back a moment and take a look at the interface. What are we seeing here? Well, here are the two synthesizers sat side by side. Synth-1 isn't used at all in this preset, so this middle section is completely redundant and we can ignore it for today. Similarly, on the right-hand side, this is a bunch of advanced controls. The init preset doesn't use any of them, and so happily we get to ignore all of this as well. There are some really powerful features in this section that we'll ultimately go on to talk about, but we don't want to overwhelm ourselves today, so let's ignore that as well. Obviously down at the bottom we've got the keyboard, and then a bunch of stuff that helps us configure how the keyboard will interact with the synthesizer. That's what all of these controls do. And then saving the best till last, the synthesizer on the left hand side, this module is what's actually generating the sound. Now at the top of the synth we have the controls that actually generate the sound. So this is what enables us to determine what the sound is going to sound like. Down at the bottom of the synthesizer we have our routing matrices that allow us to determine what the signal control path is going to be. And that's what we're going to have a little bit of a look at today. Let's start with the standard matrix. I'm going to click the zoom button so that we get a nice clear view of it. You can interact with these matrices from the lower screens. I'll just click a pin, there you go, and right click to remove it again. But it's much easier, obviously, to work in the magnified view. Okay, so down the left hand side we have our sources. These are the things that generate signals. So I want you to think about a modular synthesizer like a river. There's information flowing from the top of the mountain down to the bottom of the mountain, ultimately onto the sea, which is going to be our ears. Oscillators generate sound, and we've got two oscillators in use in this preset. So this is the two oscillator aspect of the preset title. The reference to left, by the way, means it's simply using the left-hand synthesizer of the two. It doesn't use the right-hand synthesizer at all. So typically when you're trying to figure out how a synthesizer works, you start with the oscillators, because these are the things that generate the audio level signal that's ultimately going to get to our ears. And sure enough, we've got two different signals being generated. We've got a sawtooth waveform, that's what this symbol is here. Normally a sawtooth is a right-angled triangle, but the sawtooths in this synth are capable of being manipulated. It's the only reason I can presume we've got this symbol instead, but that's basically a sawtooth. And this little pin is telling us that it's going to this filter section. Oscillator 2 is generating a pulse wave, and again, that's going to the filter section. Let's hear each of those in turn. I'm going to disable oscillator 2 by right-clicking its pin. And so now only oscillator 1 is generating any output. That's a sawtooth. Turn oscillator 1 off and oscillator 2 on. There's a pulse wave. Can you tell that the pulse wave is an octave lower than the sawtooth was. We have a very quick look at the oscillators. You can see that the oscillator 2 is operating 1 octave below oscillator 1. We'll go into much more detail about how the sound's actually generated in a subsequent episode, but today that'll do us. We've got 2 oscillators combined. Those 2 combined signals are travelling into the filter. So across the top of the matrix, we have our destinations. Where is the data flowing to? They can also be described as outputs because the signal's flowing from the oscillator, so that's the input, and it's going to an output, which is the filter. I much prefer to talk about sources and destinations. Just seems much more intuitive to me. I get less confused about which one is which, and those are the terms I'll generally use in this series. So we've got these 2 signals, they've been combined together, and they've gone into this filter section. Here's the filter oscillator. Again, not worrying particularly about how it works today. It's just a thing that's going to shape the sound. That's the thing that's making the tone, rather than it being a completely flat kind of static thing. We've got some dynamic quality, dynamic tonal quality to that sound. That's being done by the filter. So here's the trick with modular synthesizers. The filter was just a destination. Now it's become a source because the filter is now going to pass that signal onto something else. It's now the source. It's received the signal from the oscillator, done something with it. Now it's going to pass it on to the envelope. Now in the Xils-4, the envelope is actually 2 different components combined. It's actually an envelope and a voltage controlled amplifier. Technically speaking, it's the only hardwired connection in the entire synthesizer. Basically, what the envelope is doing is shaping the volume of the sound. How loud is it going to be? So when I press this key, it starts out instantaneously loud, but then it fades away. That fading away is done by the envelope shaper, and that's what ENV stands for. So in the analog world, that tiny little control voltage signal would be amplified with the voltage controlled amplifier, the VCA, and now this big hefty signal is ready to pass to the outside world. It's ready to push the cones on your speaker, drive those big magnets, end up as sound in our ears. So the envelope was a destination when it received the information from the filter, but now it's a source. Here the envelope is outputting its information to the left and right channels of our output bus, and we're going to hear it. So that's the full signal path from oscillator to filter to envelope to the outside world. But there are other pins still to discuss. The story's not quite finished. We've got this lone pin over here. We have a signal traveling from this module called Trapezoid, and it's going to the filter. A couple of things to talk about here. What on earth is Trapezoid in this context? And why have we got 2 sections in our destinations, both labelled filter? The reference to filter in the signal section is the one that takes a signal input. This time the signal's coming from the oscillators. That signal travels into the filter and we hear it. This filter definition over here is controlling one of the internal controls of the filter. It's the filter cutoff. Now the cutoff sounds like that. And this pin over here allows us to dynamically change the filter cutoff using that trapezoid shape that I talked about earlier. So now's the time for us to have a little bit more of a talk about trapezoids. The envelope shaper in this module, as I say, it's a throwback to the 60s and 70s where everything had technical definitions. It's an upslope and a flat and then a downslope. That's all a trapezoid is. Very fancy word for a very simple concept. That shape is what's allowing us to hear that change in volume over time. In this particular sound, we've only got the downslope because the upslope is vertical. If I give us an upslope, don't worry about how I'm doing it. I'm actually just increasing the attack. Now when I press a key, we have a gradual volume increase and then the gradual volume decrease. That's the trapezoid in its full glory. That shape can be applied to other components in the synthesizer. And in this case, the trapezoid shape is being applied to the filter. Every time I press a key on the keyboard, that shape is being used to sculpt the tone quality of the sound. Why is it happening every time I press a key on the keyboard? Because the keyboard triggers the trapezoid envelope. So every single time I press a key on the keyboard, this control voltage shaped like this is output from the envelope shaper and is routed into the filter cutoff to virtually turn this knob up and turn it back down again. And that's what gives us that sculpted shape of the tone. Obviously I've messed with the controls at this point. Now watch what happens when I take this pin away. Pressing keys on the keyboard, you're not hearing anything. The synthesizer is generating sound, but the filter is attenuating, basically throwing away almost all of the frequencies, because we don't have that automated increase and decrease of the cutoff knob. I'm having to do it manually in order to get any sound out of the thing. So let's put that back. And we're done with the standard matrix. We've had a look at all of those pins. Let's shut that down. Let's jump over to the advanced matrix. You'll see these 3 pins in almost every advanced matrix because these 3 pins are how the keyboard transmits its pitch information to the oscillators. If I disengage them, obviously we're only using 2 oscillators in this particular preset, but I'm going to play an octave on the keyboard. We don't have any pitch information anymore. The keyboard triggers are still firing. They're sending a signal to the envelope generator to increase the volume and hold it for a bit and then decrease the volume. But the oscillator is a completely dumb thing. It's just generating a signal. Well, there are 2 oscillators here, but they're generating this static signal, which results in us hearing a C. In order for us to hear different pitches across the keyboard, we need to send a control voltage into the oscillator to say, play a pitch that's higher than this by this amount. Every single key on the keyboard has a specific control voltage assigned to it, and when we press that particular key, the oscillator interprets that extra bit of control voltage input and says, you want me to generate a signal at this frequency. And that's what these pins do. Obviously only need the first 2 oscillators. The control voltage being output by the keyboard is completely arbitrary. I'm using the term control voltage. It's an extremely nebulous concept. It's just a voltage. Let's treat it anywhere between 0 and 1. It could be 0.01367. Completely irrelevant what the number is. The oscillator knows what to do with that information. When it receives that instruction, according to its own internal settings, it knows to increase the frequency of the output pitch by a certain amount. That's what translates into our understanding of a standard equal temperament keyboard. Even that can be manipulated. Got this control in the keyboard section called key follow. This has to be set at a very precise value in order for the keyboard to operate properly, but it is, and we won't worry about it anymore today. It seems unfair to ignore the last pin, so we'll deal with it, even though this is quite an advanced subject, so I've left it right till the very end. We've got this pin which is very slightly orange. Can you see that every single one of these pins is actually a variable control? I've clicked on it and I'm dragging up and down and I'm changing the variable control, and it was actually set to 0.5. Just as a matter, you see me changing this control here. There's no like pop-up display. When you've got one of these magnified boxes open, none of the controls on the synthesizer, you can see I'm moving knobs here, have pop-up displays to show you what their value is. If I manipulate that little orange pin down here, you can see what its value is, and it started out at 0.5. For reasons that I think are a little bit too complicated to discuss today, what's happening here is that the keyboard control voltages that I just talked about, previously they were responsible for the pitch of the oscillators. They're also being used as a modulation source to change the filter frequency cutoff. They're basically slanting the filter frequency cutoff so that the higher notes are brighter and the lower notes are duller. That's a pretty advanced subject and we're not going to worry about it too much today, but that's what this pin is doing. You add all those components together, all of those different interactions between these different modular systems, and you've got your init preset. Hope you enjoyed the episode. Please hit like if you did. I'll see you next time. Thanks very much.